Okay, solving paper 2 questions of states of matter in diffusion. The first question is the rate of diffusion of two gases, methane and ethene, is measured using the apparatus shown. So which gas will diffuse faster? Actually, we have to work out the MR, the relative molecular mass of each one, using the mass number. So in methane, carbon has mass number 12, plus hydrogen have mass number 1 times 4, so it has MR 16. So this is the MR of methane. The MR, the relative molecular mass of ethene, is 2 multiplied by 12 plus 4, so 28. Actually, the MR represents the heaviness, the mass of the molecule. So the one that will diffuse faster should be lighter. Its particles should be lighter. So the methane will diffuse faster. Why? Because its particles are lighter, so they will move faster. So the answer is C. Actually, the size of the particles doesn't affect the speed of it. The following question, the particles of substance gain energy and change from regular ordered structure, which means from the solid state, to a disordered structure with large distances between the particles, which is the gas state. So from solid to gas directly, this is called sublimation. The following question, the diagram shows an experiment to demonstrate diffusion. Actually, we have a cotton wool soaked in hydrochloric acid. It will produce hydrogen chloride gas. And cotton wool soaked in ammonia, which will produce ammonia gas. So which statement explains why the ring of ammonium chloride appears as shown much closer to the hydrochloric acid? This is because the ammonia particles are much lighter, so they will move faster. Because if you worked out the MR of the ammonia, nitrogen has mass number 14 from the periodic table, plus hydrogen have mass number 1 times 3 equals 3, so 17. The MR of ammonia is 17. Hydrogen have mass number 1. Chlorine have mass number 35.5, so the total is 36.5. So it is clear that the particles or the molecules of ammonia are lighter because they have smaller MR, so they will move faster. So the ammonia moves quicker than hydrogen chloride because it is lighter. Particles moving very slowly from an area of high concentration to an area of low concentration. This is clear that this is diffusion, because it is movement from high concentration to low concentration. This is not a change in a state, it is diffusion. So the first two answers are incorrect. Is it diffusion through a liquid or through air? Actually, it will be through liquid, because in the air particles, the diffusion will happen very fast because there are large spaces between the particles. But through the liquid, the diffusion will be much slower because there are much smaller spaces between the particles. Small crystals of purple potassium manganate, Mr158, and orange potassium dichromate, Mr294, which means that potassium dichromate have greater MR, so its particles are heavier, so they will be slower. This is the potassium dichromate. Are placed at the center of separate Petri dishes filled with agar jelly. They are left to stand under the same physical conditions. After some time, the color of each substance had spread out as shown. So the length of the arrows indicate the relative distance traveled by the particles of each substance. Which statement is correct? So as we said, potassium dichromate has greater MR, heavier, so it will move slower. Dish 1, it will move faster because it has smaller MR. So diffusion faster in dish 1. Okay, this is correct because the mass of particles is greater. Oh, this is incorrect because the particles are lighter, not greater. Okay, faster in 2? No, we said slower in 2. Slower in 1? No, we said that it is faster in 1. So diffusion is slower in 2, as we said, dish 2, because the mass of the particles is greater. Yes, the mass of the particles is heavier. So the answer is D. Pure water has boiling point 100, freezing point 0. What is the boiling point and freezing point of a sample of aqueous sodium chloride? Aqueous sodium chloride means sodium chloride dissolved in the water. which means that the water is impure. You have to know that adding impurity lowers the melting point and raises the boiling point. And something which is really important, that the melting point is same as the freezing point. Any substance melts or freezes at the same temperature. So which means that the freezing point will be below 0, which means -2. But the boiling point will be higher than 100, which is 102. So the answer is C. Okay, a compound X has melting point 71 degrees Celsius, boiling point 375. So which statement about X is correct? To be a liquid, the temperature must be between its melting point and boiling point. So 75 and 80, both of them are correct, because both of them are between 71 and 375. But to be a gas, it must be at temperature higher than its boiling point. 350 is not higher than 375, so this is incorrect. But 400 is higher than its boiling point, so it will be gas. So the answer is D. A gas is released at point Q in the apparatus shown. Which gas changes the color of the damp universe indicator paper most quickly? Okay, the quickest one is the one which has the smallest relative molecular mass, the lightest one, which is the hydrogen. But take care, hydrogen will not change the color of the universe indicator paper because it is not acidic and it is not alkaline gas. So we have to choose the next one, which is ammonia. Ammonia is alkaline gas, so it will turn the color of the universal indicator paper to blue. This is really important. I know that the hydrogen is the fastest, but it will not change the color of the universal indicator paper, so we have to choose the ammonia. Which process causes the greatest increase in distance between particles? Actually, it is sublimation, because it is direct change from the solid state to the gas state. In the solid state, the particles are very close to each other, touching, but in the gas state, they are very far away from each other. So this is the largest increase in distance. The diagram shows the arrangement of particles in 3 states of matter: solid carbon dioxide, sublimes to change to gas carbon dioxide. Which row describes the initial and the final state? Actually, the initial state is solid, so it is R. R is the solid, Q is the liquid, P is the gas. So the initial state will be R, which is the solid state. And the final state will be the gas state, which is P. So from R to P, which is C. Which statement describes sublimation? Actually, sublimation is the direct change from the solid state to the gas state. So the particles must be vibrating in the initial state, which is the solid state. So maybe it is B or C. Particles vibrating next to each other become mobile and move slowly. No, this is the description of the liquid state. This is incorrect. Particles vibrating next to each other start to move rapidly. Oh, this is the gas state, and move further apart. So this one, which is correct. Okay, a student investigated the diffusion of ammonia gas and the hydrogen chloride gas. 2 sets of apparatus were set up as shown at room temperature and pressure. So we have the ammonia gas and we have the hydrogen chloride gas. So the damp red litmus paper in apparatus 1, which contains the ammonia gas, will change color after 30 seconds. We said that the ammonia gas, it has relative molecular mass MR 17. 14 plus 3. And the hydrogen chloride gas HCl, it has MR equals to 36.5. Okay, so which means that the hydrogen chloride is much heavier. It will take more time to change the color of the litmus paper. Apparatus 1, which contains the ammonia, it requires 30 seconds. So this means that the hydrogen chloride will need more time in apparatus 2, more than 30 seconds. So how long does it take for the damp blue litmus paper to change color in apparatus 2? More than 30 seconds. So the only correct answer is 64 seconds. Okay, a gas is released at point X in the apparatus shown. Which gas turns the damp universe indicator paper red most quickly. So we have to calculate firstly the MR of each one, but we have to choose the one which is acidic because it will turn the universal indicator paper red. So if you calculated the MR of ammonia as we did before, it is 17. Chlorine is 2 multiplied by 35.5, so it is 71. HCl 36.5. Sulfur dioxide is 32 plus 2 multiplied by 16, which is 64. So I have to choose the quickest acidic one. If you choose the quickest only, the most quickly, and you didn't care about the word red, so you will choose the ammonia. But this is incorrect answer because ammonia is alkaline. So we have to choose the next one, which is the HCl, the second lightest one, because it is acidic. Ammonia gas is reacted with hydrogen chloride gas using the apparatus shown. Solid ammonium chloride is produced. Which statement explains why the solid ammonium chloride is formed nearer to the hydrogen chloride? As we said before, it will be formed nearer to the HCl because HCl has greater MR, it is heavier. Its particles is heavier, so they will move slower because it has greater MR. But the ammonia is lighter, it has MR 17. But the hydrogen chloride, it has MR 36.5. So it will be lighter and faster. So we will choose that the hydrogen chloride has a greater molecular mass than ammonia. It is heavier. Okay, hydrogen chloride gas HCl reacts with ammonia to form solid ammonium chloride. The apparatus is set up as shown. After a few minutes, solid ammonium chloride forms where the two gases meet. The experiment is repeated using hydrogen bromide, which is the HBr, in place of hydrogen chloride. How far along the tube does the ammonium bromide will be formed? Look, at the first experiment, the solid ammonium chloride is formed actually at point B. But now we replace the hydrogen chloride with HBr. So I need to know that the HBr, whether it is heavier than the hydrogen chloride or lighter, to decide they will meet at A or C. Okay, let's calculate the MR of the hydrogen chloride HCl. It has MR 36.5, which is 1 plus 35.5. The hydrogen bromide HBr, 1 plus 80, the mass number of bromine is 80. So the total is 81. Look now, hydrogen bromide, it has greater MR than the hydrogen chloride. Its particles is much heavier than the hydrogen chloride, so they will move much slower. So they will meet much closer to the hydrogen bromide, which is A, because it will be slower than the hydrogen chloride. Oxygen and fluorine are gas elements next to each other in the periodic table under the same conditions of temperature and pressure. Oxygen, which is the O2, 2 multiplied by 16, which is 32, its MR. And the fluorine, F2, its MR is 2 multiplied by 19, which is 38. So which one? Oxygen will diffuse faster because it has smaller relative molecular mass. So its molecular mass is less than that of fluorine. This one is really tricky one, so we have to focus. Gases are separated from liquid air by fractional distillation, and the boiling point of 4 gases are shown. Which gas is both monoatomic and liquid at negative 200 degrees Celsius? Monoatomic means single unbonded atoms, and this is applied for the noble gases or the inert gases, group 8. Okay, so we have to choose one which belongs to group 8, so answer D is cancelled. It is liquid at negative 200 degrees Celsius, which means it didn't reach its boiling point yet. So negative 200 degrees Celsius must be much lower than its boiling point. So it is applied for the argon. Negative 200 is much lower than negative 186. But in the helium and neon, negative 200 is much higher than the boiling point. So they will be gases at negative 200. Okay, the apparatus shown is set up after 20 minutes. A white ring of ammonium chloride is seen at the position Y. So which statement about the molecules of ammonia and hydrogen chloride is correct? This idea is repeated frequently in the past papers. So we said before that the ammonia has smaller MR. Its MR is 17, and the hydrogen chloride has MR 36.5. So this means that the ammonia is faster because it has smaller MR. So we will choose D. Molecules of ammonia have smaller MR, so they will move more quickly. Pure water boils at 100. What happens to the water particles when they boil? Actually, when we boil any liquid, the particles will gain energy. The particles will move further apart from each other. The attractive forces will be broken, will be weaker, and the particles will be arranged more randomly than before. So we will choose A. They will gain energy and move further apart. Okay, the rate of diffusion of a gas depends on its molecular mass and temperature. In which combination of molecular mass and temperature gives the slowest rate of diffusion? Okay, the molecular mass should be high, because high molecular mass means the particles are heavy, so they will move slowly. The temperature must be low, because they will have a little bit of energy. If the temperature is high, the particles will gain energy and move fast. So molecular mass high, temperature low, answer is B. Which two gases will diffuse at the same rate? Actually, to diffuse at the same rate, they must have the same MR. Okay, carbon monoxide, CO, equals 12 plus 16, which is 28. Carbon dioxide, CO2, 12 plus 32, so 44. So they do not have equal MR, so this is incorrect. Carbon monoxide, CO, we said it is 28. Nitrogen is diatomic element, N2. So 2 multiplied by 14, which is 28. So this is the one which is correct. Take care that some elements are diatomic, like hydrogen, nitrogen, oxygen, plus group 7 elements, which are called halogens. A mixture of ice and water is left to stand and the ice melts. Which row describe what happens as the ice is melting? You have to know that during the change in state, the temperature remains constant. It doesn't change. So the temperature stays the same. Why? Because the energy is used to break or to overcome the attractive forces between the particles. So the answer is D. As we see in the heating curve, the solid, when you heat the solid, the temperature increases till it melts, the temperature remains constant. When it becomes liquid, the temperature rises again, and then the temperature will remain constant during boiling. Then it will rise again when it becomes gas. So solid, liquid, gas. The formula of methane is CH4 and the formula of ethane is C2H6. Which row describes diffusion and the relative rate of diffusion? Well, diffusion, we said that it is the movement, the random movement from high concentration to low concentration. So the answer is A or B. Which one will diffuse more quickly? Actually, the one which has smaller number of carbon and hydrogen, so it has a smaller MR. So methane will diffuse faster, so the answer is B. Which test used to show that the sample of water is pure? Actually, the purity of any liquid is known by measuring its boiling point. If the boiling point is sharp or fixed specific temperature, so this means that it is pure. If it boils over a range of temperatures, so it is impure. So to check the purity of a liquid, we have to measure its boiling point. If you want to check the purity of a solid, you have to measure its melting point. So we will heat the water to check its boiling point. The answer is B. Which row about change of state is correct? So from solid to liquid is called melting, but heat energy is taken in, not given out. So this is incorrect. From gas to liquid, it is not called evaporation. So this is incorrect. It is called condensation. From solid to gas is called sublimation and heat is taken in, right. Okay. Decan has freezing point, and we said before that the freezing point is same as the melting point. Negative 30 degrees Celsius and boiling point 174. So a sample of decan is placed in an open beaker in an oven at temperature 120. 120 is between its melting and boiling point, so it will be liquid. So what will happen to the liquid? Actually, it will evaporate. It will not boil because we didn't reach the boiling point 174. Which two gases will diffuse at the same rate? This is a repeated question. As we said, carbon monoxide, which has Mr28, and nitrogen N2, which has molecular mass 28, so the answer is B. In which state does 1 cubic decimeter specific volume of methane contains the most particles? Actually, when you bring a specific volume of each state, you will find that the solid state is the one which has the greatest number of particles. In the liquid, there will be a smaller number of particles, and in the gas, much smaller number of particles. So, in the solid state.